In this video, we're going to talk about the hypotheses. There are two hypotheses that we use in statistics. One's a null hypothesis and the other is an alternative. Here are some statements about the null hypotheses. The most important part is we have to understand that it is denoted by an H with a small zero, okay, subscript 0. It's generally equal to something, or it can be shown as having no difference. No difference. Those are the key two words, no difference. If we're dealing with a specific number, you're generally going to have an equal sign. Okay? It can be greater than, it can also be greater than and equal to, or it could be less than and equal to, but in most cases it's going to be equal. So it's what you're actually trying to look at. Okay? In this one, you'll see that the correct verbiage is to reject the null. In rejecting the null, you have a statistical proof that the alternative hypothesis is correct. So let's give you an example of just basics on setting up your null hypotheses. This is one with an actual number. We're looking at the diameter of a manufactured bolt at 30 millimeters. So give you an opposite example of this would be is if we're testing let's say we're testing college students and their perceptions of the homework they're given. So you're going to run the survey, you're going to ask all the questions you need, but in the end you're going to be looking at a basic research question. Okay? You're not really going to have a null hypothesis. You're going to ask a question of what are college students' perceptions of homework presented by a college professor. Okay? And then if you were going to do a null hypothesis, you would say college students' perceptions of homework given by professors will have no difference, or there will be no difference in the perceptions of college students and homework given. If I'm going to do an alternative hypothesis in that same case, there will be a difference in college students' perceptions of homework given. But in this example on the screen here, it states the claim the assertion will be tested. The HO, and that little u there is your population mean would equal 30, meaning that the mean diameter of the bolts are actually 30. And you can see it here. It's not always about it's always about a population parameter, not a sampled statistic. So you're always looking at your population. In terms of the null hypothesis, begin with the assumption that the null hypothesis is true. In this case, everything would equal 30. Similar notion as of innocent until proven guilty. Okay? May or may not be rejected. We don't say that the null hypothesis is true. If it per se that it is 30, we would say we are rejecting the null hypothesis. The alternative, on the other hand, is the opposite of the null hypothesis and represents a researcher's claim you would like to prove. If a null is specified, there needs to be an alternative. True if the null hypothesis is false. Verbiage is we fail to reject the null and we accept the alternative hypothesis. In this case, the 30 millimeter would be H1 equals, H1 does not equal 30. Again, the opposite of the null hypothesis, the average diameter of the manufactured bolt is not equal to 30. Okay, challenges the status quo, may or may not be proven, is generally the hypothesis that the researcher is trying to prove. Here's another one. The population mean is 50. You can see on the left here the HO, population mean is 50, equals 50, and the population mean is not equal to 50 for your alternative hypothesis called an H1. So in this case, suppose the sample mean age was x equals 20, which means after we ran our test, we found out the mean age for the sample was 20. This is significantly lower than the claimed mean population of age of 50. Okay, and that's what our null and our alternative was set around. If the null hypothesis were true, the probability of getting such a different sample mean would be very small, so you reject the null hypothesis. Okay, in other words, getting a sample mean of 20 is so unlikely. If the population mean was 50, you conclude that the population mean must not be 50. Here are the 6 steps, and by the time you're done with the videos, you'll understand these. State the null hypotheses, no difference, okay, or an equal sign, and the alternative, which would be a not equal sign, or there would be a difference. Choose the level of significance, which will come up in a different one, is 0.05, and the sample size. And every sample size is different. Determine the appropriate test statistic and the sampling distribution. So you're looking at the test statistic, and the sampling distribution comes down to how was everything chosen? How were the people chosen? Was it random assignment? Determine the critical values that will divide the rejection and non-rejection region. Well, we use a 0.05 and a p-value to decide whether it's either significant or not.